Class example 4.25. Given the graph of the function f of x is equal to 9 minus x squared, let's state the domain of the function y is equal to the square root of f of x. So again, remember where y is equal to the square root of f of x is defined only where f of x is greater than or equal to 0. And again, that really means where our y values are greater than or equal to 0. So from the graph, we can see these points. They're going to be our x-intercepts. So the graph is only going to be defined between those 2 points because our graph is above 0 in this section and it's below 0 in this section. So it's only allowed in between. So we'll say x is only defined where x is greater than or equal to -3 or less than or equal to 3. In interval notation, that would be written with square brackets to show that we're including those values. Determine the coordinates of the invariant points in the transformation to y is equal to the square root of f of x, and we'll use exact values if possible. So invariant points occur where f of x is equal to 0 or 1. Well, we've already found the zeros. When y is 0, we know that the values are going to be -3 and 3. But now let's find these ones. And remember, we're looking for the x values at these points. And that's going to occur when f of x, or y, is equal to 1. So we'll set our function 9 minus x squared equal to 1. So we can solve for our x value at that point. If we move our x term to the right side and subtract 1 from both sides, we get x squared is equal to 10. So then x would be equal to the square root of 10. And remember, we get the positive and the negative version of that. So now let's sketch the graph of y is equal to the square root of f of x on the same grid. But first, let's find one key point. Let's take the square root of our vertex. And it worked out nice because it was a perfect square. It was 9. So the square root of 9 is 3. So this must be a point on the graph of the square root of f of x. And now we can connect. Remember, in between our invariant points, in this section, we're going to be above the graph. So now we want to state the range of the square root of f of x. Well, that's going to be everywhere between 0 and 3. So y is greater than or equal to 0 or less than or equal to 3. In interval notation, that would look like square brackets 0, 3.